Hello everyone and welcome to another Motec webinar. Today's subject is Introduction to Launch and Traction Control. My name is Mark McCoy and I'll be your host for this webinar. The subject today is we get a lot of questions obviously about launch and traction control. So the whole launch and traction control thing will be divided up into a number of webinars because it's a fairly broad subject. So today what I'm going to do is give you a bit of an introduction. It's mainly just to give everyone an idea of what the differences are between like launch and traction control. They are two separate sort of functions, and also a couple of options and a basic idea of what you're looking for to start with. Also clear up a bit of jargon sort of terminology as well. So more or less, like it says, an introduction rather than some hardcore traction control information, but that's still to come. Today's topics, first of all I'll just explain some terminology. It's mainly sort of Motec jargon more or less, or how we refer to things. It's always good to sort of clear it up just so everyone knows what we're talking about. What is the difference, as in what is the difference between the launch and traction control functions? What upgrades do you need for the ECU? Also an idea of how much tyre slip are we looking for, just a bit of information based on some data logging, so you've got a bit of a visual picture of what are we actually trying to achieve here with these functions. And then just some information or a couple of ideas on some helpful tools, or what I would expect is not necessarily essential for the job, but definitely a very big help. First of all, our terminology. The things that we basically have to explain the most are the difference between our ground speed and drive speed, and what we sort of mean by those. Ground speed is simply the non-driven or the rolling wheels. You can have one wheel or two wheels. If you have two wheels being measured for speed, then the ECU will use the fastest of the two. It doesn't average in the ECU, it just simply uses the fastest. So what we are sort of considering with a ground speed measurement from the wheels is a two-wheel drive car, either a front-wheel drive or a rear-wheel drive car. The biggest problem we have with doing traction control on a four-wheel drive car is working out how fast that car is actually moving across the ground. What we are ultimately referencing for traction control at least is how fast is the car physically moving across the ground as compared to how fast are the wheels turning. The difference between the two is what we're trying to control. So on a four-wheel drive car you start looking at things like GPS, or even extra ground speed sensors which aren't actually connected to the wheels and stuff. It gets a little bit complicated. But ground speed, that is how fast is the car moving across the ground. On a two-wheel drive car it's the non-driven wheels. Drive speed, as people might suspect, is the wheel speed that the engine is actually driving. So again, we can measure either one wheel or two wheels. Now if we measure two wheels, say on a rear-wheel drive car, the ECU calculates a balance of the two. Now this is to take into account things like different type of differentials, like an open center differential, a limited slip, or even a full spool or a locker as they're called. Ground speed, drive speed, same thing for on a bike, but obviously we're only going to be having one ground speed and one drive speed on a bike, but still basically works the same. We have a couple of other options with our 100 series ECU and M84 ECU, in that we can do traction control based on the RPM rate of change or the ground speed rate of change. Now this can come into effect on things like four-wheel drive cars, like I was saying before, where ground speed is actually hard to measure, but the RPM rate of change or the ground speed rate of change, and in a four-wheel drive car that ground speed would be a driven wheel as well. What we're sort of doing is, if you think about it, if the car breaks into wheel spin, the RPM or the ground speed measurement is going to change quicker than would be good for traction to accelerate the car. So what we can actually do is control how quickly the engine accelerates, and therefore how quickly the wheels accelerate, and therefore ultimately how quickly the car accelerates. So they're a rate of change type traction control. Slip, the thing we're ultimately messing around with and wanting to keep an eye on, is simply the difference between ground speed and drive speed, and we can measure that as just a straight kilometers an hour difference, but it's more usual to measure that as a percentage. Say the back wheels on a rear-wheel drive car going 10% faster than the front wheels, and so we control to a percentage of slip. So slip is something you'll be hearing about a lot, because that's ultimately what the traction and launch control are trying to adjust and keep in the sweet spot. Launch control, as I said before, launch and traction control are two separate functions. I find that a fair few people get a little bit confused, and I think that's mainly like a terminology thing. So just to clear up the terminology as Motec sees it, launch control, quite simply when the car is stationary and you need to take off, or you need to launch in first gear. So whether that's a drag race, a circuit car, rally car, bike, or whatever, launch control is we are stopped and now we need to start moving as quickly as possible. Traction control, that is controlling the tyre slip once the car is moving. So we're halfway down the quarter mile, or we are going around the circuit, the car's already moving, we're not launching it, but we still want to control slip. Dual RPM limit is a third option, and I mention this because it's a nice simple way of launching a car. Again, it's just launch, and effectively what we do is we have a button, like maybe on the clutch or on the steering wheel, which simply holds a different RPM limit from the main RPM limiter, and that's only used for launch. Now the launch control and dual RPM limit are what we call an open loop system. Now if you want to watch my PID webinars, that will give you a bit of an idea between the open loop and the closed loop. But effectively we're not using any feedback, we're just simply saying at this certain situation give us this amount of RPM. It's got no feedback as to what the tyres are actually doing, we're just simply mapping an RPM based on a launch. Traction control, on the other hand, is a closed loop system where it's constantly working out what is our tyre slip, and we've given it an aim tyre slip, and it works out the difference between the two, and it tries to always adjust everything to control to an aim slip that it's been told that we want. So just a bit more detail here. Here's a launch control map that I've got on a customer's car. Now the launch control is an RPM limit table based on ground speed, effectively. So what we are saying, from 0 kilometers an hour we want a certain RPM, 5 kilometers an hour give us a different RPM, change the RPM limiter based on ground speed. Now what we would normally do is have this mapped for first gear. So if first gear runs out at 60 kilometers an hour before we have to change to second, your launch control would be mapped as purely RPM right up to 60 kilometers an hour. Now you'll notice in my first point there I say that the limiter is based on ground speed or other. Now the other is kind of up to your imagination. If you remember things like the four-wheel drive car, we don't really have ground speed or a decent measure of ground speed. So various things that people are using are things like timers. So when you let go of the clutch, the timer starts. So instead of ground speed being our x-axis along the top here, we actually have a timer. So at 0.1 second we have a certain amount of RPM, 0.2 seconds, up to 1 or 2 seconds after launch. Another thing I have here down on the y-axis, I have a traction control trim pot. So this particular customer has the ability with a 9-position switch on the steering wheel to change. So if he goes out on the track and suddenly it starts to rain, he can adjust his launch control to suit something that he would have tested before for wet conditions, dry conditions, hot, cold, different tyres, those kind of things. And just to be a bit smart, down the bottom you can see we've got a more or less an off sort of situation where he can, that's what we would call the burnout mode, or if he wants to go out and do donuts because he's won the race, he can simply change it into a mode that will allow him to do that as well. The launch control is purely a fuel and ignition cut or retard as well we can add in. So for people thinking of using drive-by-wire for launch control, the launch control is only a cut and retard type of function. It doesn't use the drive-by-wire, although for the smart people amongst you, I'm sure with various access setups for the drive-by-wire throttle translation you can have something based on launch as well, but the actual function launch control and dual RPM limit for that matter is a fuel and ignition cut, and you can also add some retard as well. For traction control, we're a little bit different here in that we use an aim slip table or rate of change table. So as I said before, slip is simply the difference between the driven wheels and the non-driven wheels. What we are saying, based on some testing, is we are giving the ECU an amount of slip that we want. So the ECU measures the actual slip, what the wheels are doing, it compares it to what we've asked it to do, and it adjusts its control to vary the engine power to get the slip that we've told it. So again, with a closed loop system, we are giving it something to aim for, the aim slip or the rate of change. It simply monitors what's actually going on and adjusts the engine power to try and bring those two into line. Now with traction control we can use cut and retard, or we can even use the drive-by-wire throttle, which is something becoming a little more popular these days. So what I've done here is my table, just for a bit of an explanation of how intricate they can get these days, is we have a ground speed along the top. So as ground speed changes, if you look at the numbers, we sort of change the amount of slip that's available. And I also have a lateral g-force. This being a circuit car, a tyre can only give its maximum grip in a certain direction. So if you're going in a straight line, you can put all of its grip into going into a straight line. But if you're going around a corner, hey, it's using up some of that grip to maintain the corner. You can't put all that slip into driving the car forward and accelerating it, so you kind of have to drop a little bit so that the car doesn't go spinning off the track. So this is something we sort of do a fair bit these days. There's also a couple of tables to adjust this aim slip table. I would have something like a 9-position switch, as I mentioned before, and I'd have a few different settings for whether it's a wet track or a dry track. But overall, we give the ECU an idea of what slip we want. It does the control based on what it's actually seeing at the time. The dual RPM limit, as I've said before as well, it's a very simple function. Basically we have a switch, be it on the clutch or on the steering wheel, and we simply hold it to a low RPM limit. So what's the RPM we want to launch at, and then after that we have a RPM rise rate. So it's an RPM rate of change type of function once the button is released or the system becomes inactive. And we can also add a fixed retard. Now you'll notice that these are simply parameters, they're not tables. So you can sort of see, but between the dual RPM limit and the full launch control, the dual RPM limit is not a very flexible sort of function. It works quite well, but realistically it's the full launch control system that we actually want to use. What are the options? Well, dual RPM limit, it's a standard function on all of our ECUs, so no matter what level of upgrade you have, you always will have dual RPM limit. So if you're at the track and you've got your clutch switch, you at least have some function that you can use and have a bit of a play with. The launch and traction control, that comes as one full sort of function, so you can't buy launch and traction control separate. You buy both of them or neither of them. They are included in the advanced functions upgrade for the 100 series ECUs, or the 400, 600, 800 and the M80. So if you buy the advanced functions, as well as like a couple of other functions, you get the launch and traction control. On an M84, which is our new ECU, the launch and traction control again are included in the advanced functions, or you can actually buy it as a separate sort of function. So you can just buy launch and traction control without the other parts of advanced functions if you want. So just slight difference between the two. Okay, ultimately, what are we looking for? A tyre will produce a certain amount of grip at a certain amount of slip. Now, as you can see on my data logging here, at 0 slip we make 0 grip. So to make a tyre produce traction, we actually have to have it slipping. So effectively, if the car is accelerating, and I'm talking street car, race car, or whatever, if the car is accelerating, it is producing slip. Now, we're not talking about a big smoky burnout here. We are simply talking about the way a tyre works. It has to produce some slip to produce grip. Now, if you'll notice, if we give it a bit more slip, we get more grip. Hey, that means we can make better use of the engine's power, and it'll come up and rise to a maximum. So we get a maximum amount of forward acceleration, if you want to put it that way. But then if we go a little bit too far, well, there's a problem there. We start to lose grip, and then once we get to about this point here, it just shoots off at a sort of fixed level of longitudinal acceleration or grip, and that's basically when we start smoking the tyres. So ultimately, what we are trying to do is maintain the highest level of grip, and what I've done here is simply log the amount of slip. So I've logged ground speed, drive speed, and I've got my slip channel, again the difference between the two, and in this case I've also logged a longitudinal g-force sensor, so I can see how much force or how much longitudinal acceleration I have based on the comparison to slip. So we can see here, hopefully that shows up fairly well on your screens, that between about 2.5% slip and about 4.5% slip, we make the maximum amount of grip. So realistically, you could probably drop it down a bit below 2% slip and right up to about 5% slip, and if we maintain that kind of slip around our track or down the quarter mile, we'll be using the tyres to their fullest. Now, obviously, that curve there is going to change for tyre conditions, tyre type, and also track conditions. So realistically, you would have to do some fairly comprehensive logging just to get a really good idea of what your tyre is actually doing. The colour scale over here I've done as ground speed, so I'm comparing how the tyre works in a straight line at low speeds, say in first and second gear, all the way up to if I'm in fourth gear or fifth gear or something like that. The other thing you would do, just alluding back to my aim slip table with lateral G, is we could also use the comparison of lateral G. So when I'm going through a corner, how much slip am I allowed to make the car accelerate forward? And you'll find that will be a fair bit less. So this actual curve here, even for the one tyre, will move around depending on conditions. So the smart guys will be thinking, what can we compare slip to make sure we are using these tyres at their maximum grip. So I can guarantee that in a corner you are going to get away with a lot less slip to accelerate the car than if you were in a straight line. So this is what you have to be looking for these days, and it makes a big difference on a circuit car, that's for sure. If you're lucky enough to have a drag racing car, well, don't worry about lateral G's, it's not really going to affect you. Okay. Helpful tools. Logging is the first one, and I say helpful tool, but I would, as I say there, it should be considered pretty much indispensable these days. If you're trying to set up all of these wonderful functions on your Motec ECU and you don't have data logging, I would suggest that you are not doing the best job that you could. The driver cannot remember 64 channels at up to 200 times a second and how each of them compare. The ECU can with your data logging, or even if you're lucky enough to have a dash logger as well. Longitudinal G sensor, very, very helpful, but if you have the Pro Analysis upgrade for your device, you could think, well, longitudinal G's and ground speed rate of change are similar kind of thing, so instead of using longitudinal G's, I'm just going to look for the maximum speed change, or the maximum rate that the car will accelerate at. Lateral G sensor, as I said, for the circuit, and I would suggest if you're doing traction control for a reasonably high horsepower circuit car, you really need to spend the money and get a lateral G sensor, because otherwise you're compromising the traction control for corners or for in the straights. So if you can't divide the two up, then the traction control is going to be compromised. So a lateral G sensor for the money is going to make all the difference for a circuit car especially. For launch control, and I'll get into this possibly in the next webinar, which will be based on launch control, just know what the RPM versus drive speed for, say, first gear is. So for launch control, remember we are doing an RPM limit based on ground speed, and what we're going to want to know is, okay, if I've got a certain ground speed, non-driven wheels, and I know that I want a certain amount of wheel spin for the rear wheels, I sort of need to know the relationship between drive speed and the RPM. So have that as a bit of information close at hand, and that will certainly help. Okay guys, thanks for everyone for attending this webinar. As always, the webinars are being recorded and they will go up on our website later on today. And if you're not already a member of our forum, I would suggest joining that too once we've closed up shop for the day. And if you need a question answered, you can usually throw it on the forum, and someone in another part of the world in a different time zone can potentially answer that for you and get back to you quicker than we can if we're not here. So thanks again for attending, and I hope you can attend more of these webinars. Thank you.